Hello, today we're going to be simplifying rational expressions that include opposites. Before we jump into binomials and trinomials, let's think about just a constant monomial. The opposite of positive 4 would be negative 4. If we divide those, positive 4 divided by negative 4, that's going to leave us with a negative 1. Because 4 goes into itself one time, and then a positive divided by negative is a negative. So let's try that with binomials. Let's say we have x minus 1 over 1 minus x. Well, I notice that this is positive, but that's negative. So I have a positive x and a negative x, and I have a positive 1 and a negative 1. So both parts are opposites. So let's see what happens. Let's see if it's going to be negative 1 or not. So let's use some techniques we've used before. So we're going to be factoring. So we can't factor x minus 1, so we leave that alone. So when we look at this 1 minus x, they don't really have a common factor, but we normally don't like for our highest degree variable to be negative when we're actually trying to factor. So a technique we used with that was to take out a negative 1. So let's try that. Let's divide both by negative 1, and that will give me negative 1, and a negative divided by a negative is a positive. And I want to keep that negative 1 on the outside. So this is really, if I rearrange my terms by the commutative property, that would be x minus 1. So I can rewrite this expression as the opposite of x minus 1. And we can distribute the negative to check it real quick. That'd be the opposite of x, and then a negative times a negative makes that positive 1. Well, now I have a common binomial factor. I can cancel out the x minus 1s, and I have 1 divided by negative 1, which is negative 1. Oh, so whether we're doing monomial constants or we're doing binomials, if we divide opposites, we get negative 1. So let's use that to actually factor some rational expressions that are a little more complicated. Let's say we have n squared minus 4 over 2 minus n. Remember, we can't cancel terms, so we need factors. So we're going to factor the numerator, and I see that that is a dots, a difference of 2 squares. So this is our rule, a squared minus b squared is equal to a plus b, a minus b. Okay, so that means this is going to factor into 2 sets of parentheses. What do we square to get n squared? That would be n. What do we square to get 4? That would be 2. Then our rule says we need opposites. Okay, so our numerator, we have n plus 2, n minus 2. And in that denominator, we have 2 minus n. Now, we could go through factoring out a negative, but we've already seen that if we divide opposites, then we're just going to be left with negative 1. So we'll check to make sure both terms are opposites. I have a positive n, a negative 2, a positive 2. So this whole binomial is going to cancel into the top, leaving me with a negative 1. So that leaves me with negative 1 times n plus 2. And we can distribute that negative, so it'll be negative n minus 2 for our simplified answer. In our next example, we'll look at trinomials that involve opposites. I see that I can factor my numerator, and we'll use the T method, and my A is 1, so I really just need to look at factors of C. So we'll list things that go into 56. 56 divided by 2 is 28. 3 doesn't go, 4 goes 14 times. And then not 5 or 6, 7. That was a clue there because we know 7 goes into 28. So 56 divided by 7 is 8. Okay. And remember, if that's negative, if we have a negative C, that's where we're going to have opposites. So that's going to be a positive times a negative or a negative times a positive. And with different signs, we're actually subtracting to get our middle term, which was -1. Back up there a little bit. So as I'm looking at the factors, I need for them to subtract to give me a -1. Looks like 8 and 7 will work. And if I make 8 the negative, that will give me the correct sign. So we can just put that in our binomial factors. Only one way to get x squared. And this was our combination to get the correct middle term and the last term. So this will be x plus 7, x minus 8. Now we'll look at the denominator and factor it. And I notice this backwards. It is not in standard form. So if I rearrange those terms, I have -x squared plus 7x plus 8. And when we're factoring, we do not want a to be negative. So we divide through by -1 to solve that problem. And we're factoring it out. We're not actually, we don't have an equation. When you have, then you can just divide both sides by a common factor. But here we have an expression, so we do not want to throw away what we're factoring out. So hang on to that negative. And that'll leave us with positive x squared minus 7x minus 8. And now we have a trinomial in standard form. We can focus on just the c since our a is 1. So we need factors of 8, 1 times 8, 2 times 4. Since that is negative, we are looking to subtract those factors to get 7. So 1 and 8 would be the correct combo, but we need a -7, so our larger number needs to be negative. So now we know what our factors are going to be in our binomial. We'll have x plus 1 and x minus 8. So that's what we're going to put in the denominator. So now we have factored the numerator and the denominator, and I notice that I have an identical set of binomials here. So I have x minus 8 divided by x minus 8, which is 1. So that leaves me with x plus 7 over the opposite of x plus 1. We do not like to leave negatives in the denominator. So we think about, well, that would be a +1 we could factor out, and 1 divided by -1 makes the whole thing negative. Okay, and usually you just write that in the middle. Now, when we start adding and subtracting these, it's to your benefit to go ahead and distribute the negative into the numerator. So it'd be the opposite of x, the opposite of 7, all over x plus 1. And that will be our simplified expression. Okay, well, I hope you've enjoyed this video. If you find it helpful, please share, like, or subscribe, or all three. Thank you. Have a great day.